Hello again, 8th grade, and welcome to today's lesson. This is Math with Miss You, Miss Me, and we are learning about the power of a product and power of a quotient rule today. That's the lesson, right? So pause the video now, make sure you have everything you need. You're going to need a paper or a piece of paper and a pencil so that you can copy down some notes and send that to me on Google Classroom. Alright, so the standard today is AEE1, as we've been learning about all week, and this is your last lesson for the week because tomorrow you have a quiz. Alright, so if you have not looked at the lessons yet, please make sure you do so. You're going to want to know all the properties of exponents so that you can be prepared for your quiz. Alright, so the first thing we'll do in this lesson is we'll review those very quickly, and then we'll go on to the power of a product and power of a quotient rule, which we actually have seen when we did the power of a power property. I threw it in there, but we're going to look at a different aspect of it today. These are the properties of exponents we have learned so far. The product of powers says keep the base and add the exponent when the base is the same. Quotient of powers says keep the base and subtract the exponents when the bases are the same. Power of a power property says keep the base and multiply the exponents when you are raising a power to another power. The zeroth exponent property says any number raised to the power of 0 is equal to 1. And when you are rewriting negative exponents with a positive exponent, you take the reciprocal of the base and the opposite exponent. So you keep the base, change the sign, flip the number. So today we are going to look at power of a product and power of a quotient property. These are the two things you're going to write in your notes. So power of a product property says that if you have a product, right, A times B here is our product because the product is an answer of a multiplication problem. You have a product and you raise it to a power. Each of the numbers that are being multiplied in that product are going to get a little piece of this exponent. Right? And on the reverse, and when I say reverse, I mean flip side, if you have two exponential expressions being multiplied and they have the same exponent, you can multiply those bases and keep the exponent. Alright? What's happening here is the top is the reverse of the bottom and vice versa. And you're going to see the same exact thing when we are working with power of a quotient property. And if it's confusing now, it'll make a lot more sense once we get into the examples. So power of a quotient is you're taking a quotient, right? It's in the form of a fraction here because fraction is dividing and a quotient is the answer to a division problem. So you take the power of a quotient and you're going to share that exponent to both the numerator and denominator, the top and the bottom. So that becomes a to the m over b to the m. And just like before, power of a quotient property also says that if you have two exponential expressions that are being divided and they have different bases and the same exponent, you can divide the bases and keep the exponent. Notice how I also added parentheses with both of those. Okay? Pause the video right now and copy these into your notes, please, and thank you. And once you have copied it into your notes, I also want you to copy the steps. how to apply the power of a product or quotient rule. So you rewrite the expression as the product or quotient of the bases, and then you evaluate. Remember, evaluate means to solve, so you can get an answer, get the value. Get the value of the bases and raise to a common exponent. So here we have the power of a product property, and what I'm going to do for you is I'm going to use numbers. I'm going to substitute the number 2 for A and the number 3 for B, and I'm going to make the exponent, which is m, 2. Alright, so this becomes 2 times 3 to the second power. So 2 times 3 to the second power, according to the power of a product property, I would distribute the exponent to the 2 and the 3. So I get 2 to the second power times 3 to the second power. And if I were to evaluate this, and remember I just told you evaluate means to get the value, 2 to the second power is 4, and 3 to the second power is 9. And 4 times 9 is equal to 36. Now if I did it the opposite way, and I decided to multiply 2 and 3 first, 2 times 3 is 6. And I would have to then keep that exponent, so 6 to the second power. And 6 to the second power, which is 6 times 6, is 36. So take a look at that. Here's an example for why the power of a product property works. Now let's take a look at why the power of a quotient property works. I'm going to say that A is equal to 3, B is equal to 6, and M is equal to 2. So my exponent will be 2. So when I substitute that, I'm going to get 3 over 6 to the second power. Now the power of a quotient property tells me to share that exponent to the top and the bottom, all the terms on the top and the bottom. So what I would get is 3 to the second power on top and 6 to the second power on the bottom. 3 to the second power, or 3 squared, is equal to 9. 6 to the second power, or 6 squared, is equal to 36. And 9 over 36 simplifies to 1 over 4. And if I decide I'm going to simplify what's inside of the parentheses first, 3 divided by 6 is 1/2. And I would have to keep that exponent, because that says 1/2 squared, which is 1/2 times 1/2, which is 1 over 4. So here is an example of why the power of a quotient property works. Now let's get into our mini lesson. Here is problem number 1 for the I do. Please copy it down. It says, can the expression 4 to the second power times 6 to the second power be written with one base and one exponent as 24 to the second power? Prove your thinking. What I'm going to do is I'm going to expand this expression. 4 to the second power times 6 to the second power can be written as 4 times 4 times 6 times 6. And then I can rearrange this. So it says 4 times 6 times 4 times 6. And I know that 4 times 6 is 24, 4 times 6 is 24, and 24 times 24 is 24 to the second power. So using the commutative property, which allows me to move the numbers as I need to, and the associative property, which allows me to group them as I need to, with multiplication, of course, that is how I can prove that 4 to the second power times 6 to the second power is equivalent to 24 to the second power. So I'm going to answer the question by saying yes. Alright, please make sure you copy that down. Pause the video now so you can do so. Alright, now let's take a look at the second question. It says simplify 15 to the second power divided by 3 to the second power. So we are looking at a quotient here. We see that there are two different bases, but the same exponent. So using the quotient of powers property, what I can do is I can say that this is equal to 15 over 3 to the second power, which is equal to 5 to the second power, because 15 divided by 3 is 5, and 5 to the second power is 25. So now let's take a look at the redo. What I would like for you to do now is go ahead and pause the video and attempt these two on your own. And once you're done with that attempt, play it back and see how you did.